Hi guys, I hope you are all doing well. Let's see today's question. So today's question we are taking this up from the topic of conics, and particularly if I talk about the concept that we are taking this question from, it is hyperbola. So let's figure out the question. First, the question tells us let Hn, which is having an equation as x square over 1 plus n minus y square over 3 plus n is equal to 1, where we have been told that n belongs to natural numbers. The question further tells us k be the smallest value. So we have been given smallest even value of n such that eccentricity of hk, it's a rational number. So we have been given eccentricity of this hyperbola is a rational number. Further, it's telling you if L is the length of the latus rectum. So we have been given latus rectum of hk is L. The question is further asking us to figure out what is the value of 21 times L. So we have to figure out the answer for this question that is given to us. And if I talk about the answer choices that we have here, the options are 42, 210, 306, and the fourth option that is given to us that says 420. So we need to figure out which one of the answer choices is the correct answer for this question that is given to us. So let's first try to solve this equation. So if I have my hyperbola equation, it says x square over 1 plus n minus y square over 3 plus n is equal to 1, where n belongs to natural numbers. So when I have this, if I compare it with my original equation of the hyperbola, which says x square over a square minus y square over b square equals 1. So from here, I get a square is 1 plus n, b square is 3 plus n. So once I have a square and b square with me, I can just figure out the eccentricity of this hyperbola. So eccentricity E, it's given by square root of 1 plus b square over a square. Now once I have square root of 1 plus b square over a square, I can just figure out this by putting the values of b square and a square. So that gives you root of 1 plus b square, it's 3 plus n, a square, it's 1 plus n. So if I take the square root of that entire thing, I have 1 plus n plus 3 plus n divided by 1 plus n. So from here I get my eccentricity, which is square root of 4 plus 2n divided by 1 plus n. So I get 2 common, n plus 2 divided by n plus 1. So I have my eccentricity in terms of n. Now once I have my eccentricity in terms of n, I understand that the question tells us that the eccentricity of this is basically a rational number. When it is a rational number, I know I can have a perfect square inside the square root. So when it comes out, it gives you a correct rational number. Because if there is not a perfect square inside the square root, then it will become an irrational number. So I should have a perfect square in this root. When I have to have a perfect square, basically that also tells me that your numerator as well as your denominator, both of them should be individually perfect squares. So when both of them should be individually perfect squares, I understand that square root of n plus 1 should be a perfect square, and square root of 2 into n plus 2 also should be a perfect square. So let's see. And we have been also told one condition about n, that n belongs to natural numbers and it is the smallest even value of n that is holded by k here. So if I see for some different even values of n, I can understand from the denominator that something plus 1 should be a perfect square. So something plus 1, and n being an even number, we have been told. So even plus odd, we know basically it is an odd number. So we should have odd perfect squares. So if I try to tell and talk about the odd perfect squares, if we start off, we know 1 is your first odd number, so 1 square is 1. So to have a denominator 1, n should become 0, but we have been told that n belongs to natural numbers. So for that, I know that when 1 square is 1, n should be equal to 0, but that's not possible according to the condition given. If I see the next odd number squared, which is 3 squared, so 3 square is 9. And when I have to have denominator as 9, n plus 1 is 9, and that's only possible when n is equals to 8. So when n is equals to 8, if I'm putting in the numerator, let's see. So 8 plus 2, 10, 10 into 2, 20. So I'm getting numerator 20, which is not a perfect square. So this is also not possible. If I see next odd number, it's 5 square, which is 25. To have 25 in the denominator, n should become 24. So if I put n as 24 in the numerator, gives you 24 plus 2, 26, 26 into 2, 52, which also is not a perfect square. So this is also gone. If I see the next odd number, that's 7 square, 49. For 49 in the denominator, n should become 48. If I put n as 48 in my numerator, let's check. So 48 plus 2, 50, 50 into 2, which is 100. So your numerator turns 100 and your denominator is 49. So your eccentricity here, if I see, it gives you a perfect square in individually both numerator and denominator. And from there, you get E is equals to square root of 48 plus 2, 50, 50 into 200 divided by 48 plus 1, which is 49. So that gives you E as 10 over 7. So from here I get E is nothing but 10 over 7. That's your eccentricity. And once I get E as 10 over 7, the question is further asking you to figure out the length of latus rectum. So let's figure out first A square and B square. So A square, we know from the expression that it is 1 plus n, and B square is 3 plus n. So A square is 1 plus n. 1 plus n, which is 1 plus 48, which is 49. And B square, it's given to me 3 plus n. 3 plus 48, which is 51. So I have A square with me, I have B square with me. Now let's just figure out the new value of the expression that's asked to us. That says you have to figure out the value of 21 times length of latus rectum, and length of latus rectum we have been given 2b square over A. So that gives you 42 b square. So this 51 square. A, which is, if I figure out from here, it is 7. So 7. 7 1 times, 7 6 times. So 6 times 51 square. So if I see here, from here I know b square, it's not 51 square, it's just 51. So we should not write 51 square here. So I get from here 6 into 51 is the value. And once I have that with me, 6 ones is 6 and 6 into 5 is 30. So I get the answer for the question that is asked to us, that 21 times L is equal to 306. That matches with option C. So C becomes the correct answer for the question that is given to us here. I hope you have understood how to solve this type of questions on hyperbola. So we just compared our questions equation with your general equation of hyperbola. We got a square, we got b square. From there, we got eccentricity, which is root of 1 plus b square over a square. Once I got that, I just figured out the value of n I should have to have my eccentricity of the hyperbola as a rational number, which was given to us as E of Hk. So I got from here that n should be 48 in that case, and when n is 48, your eccentricity turns out to become 10 over 7. Once I get that, I got A, I got B square, I got 21 times L question to be figured out, and that came out to become 306. So that matches with option C, and C becomes the correct answer for the question that is given to us. I hope you have understood how to solve this type of questions. I'll see you again tomorrow with some other question from some other topic. And we are going to continue our series of questions on JEE mains. So stay tuned for more videos to roll out. Also, if you're enjoying these videos that we are doing on everyday basis, please do like the videos as well, and do subscribe to my channel, and share these videos with your friends also who are involved in the preparation of questions on JEE, so they can also take the benefit from these questions which we are solving on everyday basis. Thank you.